Oh, hello there. I didn't see you come in. Ha ha ha, what a funny joke. We're going to be going over example 13 right here. So, get that loaded up. All right. And away we go. For example 13, we have a regular Atwood machine, which means it's just a regular pulley. You see those two blocks, A and B. One has a mass of 50 kilograms. Zoom in a little bit. And the other has a mass of 30 kilograms. So the nice thing is your intuition should be absolutely correct. The heavier one between these two blocks, the heavier one is going to be the one that falls while the other one raises up. So block A right there is the heavier one. So A is going to be going down, which for us, that's going to tell us which direction we want to be positive. So on the left side, on the A side, we're going to say down is positive. All right? So the direction the block is moving is always the positive direction for this when it first starts. So block A is falling down, so that's the positive direction. Over here, block B is going to get it lifted up. So block B is the positive direction for block B is going up. And as it goes around, right, you can kind of see the consistency with those directions. So they're always pointing the same direction. It's just flipped a little bit from the A side to the B side. So we set that up there. And then I know we have masses, and it's asking us about acceleration. So that's the ingredients for us to use Newton's second law. So I'm going to set up the net force is equal to mass of our system times acceleration. And from there, I just need to know what the net force is. So the net force acting on my system is both of those blocks together make my system. So I have the weight of block A trying to pull it down, and I have the weight of block B trying to counteract that. It's slowing it down. So when I do my forces acting on it, if you take a look right there, the forces for A, the weight of A is pointing in the positive direction. So that's a positive weight of A. And then if you look here, if we look at the direction B, the weight of B is pointing down. Well, that's the negative direction on B's side. So that's going to be a negative force. And then that's equal to the mass of both my objects put together times A. And my goal now is solve for this acceleration that we have right there. And all I'm trying to do is solve for that A. I got one other little substitution I can make. I know that the weight, let's go, remember for force of gravity, the weight is equal to the mass of the object times the gravitational field strength, how much it's getting pulled down. So if we substitute those in, that's the mass of A times G minus the mass of block B times G. And that's all equal to nothing on the right side changes. Still just trying to solve for A. All right. So now I'm going to actually solve for A. I'm going to divide both sides by this quantity right there. So A is equal to MA minus MB, and we can actually, because there's a G on each of those terms, we can factor that G out. And that's MA plus MB. And one extra little step we can do just to make it nice and pretty, we can put all those masses together. MA minus MB in the numerator, MA plus MB in the denominator, and then we put that G outside, just to make it, that's for like the math purists that want to see all the formulas and real nice and pretty. And so now that I have my formula all set up, I just need to plug in the numbers. So plugging in the numbers here, that would be 50 minus 30 kilograms, all divided by 50 plus 30 kilograms. And then G is 10 newtons for every kilogram of mass. Okay, so This turns into 1/4, 0.25 times 10. So our answer ends up being an acceleration of 2.5 meters per second every second. Okay? So when we let those blocks go and they start to fall, that's the rate that both those blocks are accelerating at. Okay? So now we go back to part B, and it says, how long will it take that block to move 2 meters upward? So how long? Right away, I know I'm dealing with time. It's asking me how long it's going to take to do something. And if I'm dealing with time, I'm dealing with kinematics. Right? That's a motion type problem. So if I'm dealing with kinematics, I need to figure out all the other stuff that I have. So I know it's moving 2 meters upwards. So that's a displacement. And because it's moving, B is moving up 2 meters. That's in the positive direction. So it's positive 2. If we just let it go from holding it, that means it's going to start at rest. So that's initial velocity is 0. And we have the acceleration you just figured out in part A. 2.5 meters per second every second. All right. Those values right there is what we have to work with. And if you know 3 pieces of motion information, that's enough for us to use one of our kinematic equations. Okay. So the equation we'll end up using looks like this. We just need to, my recommendation is make your life a little easier. If you look at your values and you have 0 for any one of those values, like you do for initial velocity, use that to make the equation a little simpler. So when I plug 0 in, it makes that entire term go away. So, like I said, make your life a little easy. Simplify the equation. Just makes the math a little easier as you're working out. And now we got to solve for t. So when I solve that equation for t, for time, I end up with the square root of 2 times the displacement over the acceleration. And once you plug in your numbers, 2 times 2 meters over 2.5, that comes out to approximately 1.3, not meters per second, seconds. All right? So that's our second part. And our third part is saying, hey, what will its velocity be? So again, I have it's asking me final velocity at that same point 2 meters above where it started. So it's after it's done all the same stuff from part B, how fast will it be going? That's what it's asking. So since it's all the same stuff, let's just steal all of these motion values and put them down here. The only difference is now we actually know the time. The time was, you just figured out 1.3 seconds. So with all this info, now we just pick one of our kinematic equations to use. Let's go the one that actually says final velocity equals acceleration times time. Plug in your values. We know the acceleration is 2.5. The time is 1.3 seconds, and the initial velocity was 0. So that gives us a final velocity of 3.25 meters per second. All right? If you guys have any questions, make sure you ask me in class. You can even write a comment if you want. And I will see you guys